All right. Hey, listen, welcome back, everybody. You're here with the Sandoval Crew, and we're going to go ahead and do the first video notes for geometry. So with that, let me go ahead and share the screen. And one thing you're going to discover is that this is geometry, and what we're going to do today, we're going to learn about points, lines, and planes. Now, one thing that I love is that for the most part, you have done this for years. This is not new for most of you. If anything, is going to be a lot of definitions, but most of them you're going to recognize because you have the benefit of doing them before. Okay, so with that, let me go ahead and let's start with Celeste. Celeste, why don't you go ahead and read the this first slide?
The three undefined terms in geometry are point, line, plane. They are building blocks of geometry.
Now, hey Marcus, why are they called undefined terms?
Because you can't really define them, you could only show them.
Yeah, pretty much we really can't prove how they exist. We just know they do. You know, it's like, how do you prove a number is unique? You know, like 0, 0, and 1 is 1. And you're like, oh, they just are. It's the same thing here. They just are, right? That's the thing that we have said, but there's no really proven method behind it. All right, good. All right, Max, go ahead and read this next one. Oh, you know what? Let me do this. Hold on a second. Let me change the view for a second because it's like, see if this works a little bit. Yeah. Hey, can you guys still see that? Or should I zoom in a little bit?
Zoom in a little bit.
Zoom in? Okay, so let me go ahead and zoom in by percentages. Let's do it a little bit more. There you go. All right. Is that better? Okay, good. Max, go ahead and read this one.
What is a point? A point is a location or a position in a space. It has no length, width, or thickness.
Yeah. So, Marcus, so if you had to locate a point, what would you do?
I'll just point at something, I guess.
Yeah, I guess so, right? It's just a position. Actually, if we would have been in classes, I would actually had you playing with Play-Doh. And most people would make point with like almost like, and they would actually make a ball, and then I'll say that's not a point. And what would you need to do to make it a point?
Just use.
You point at the center.
No, you couldn't. You know what you would have to do? I would say you need to flatten it. I would put it on the table and make it completely flat. You know, like a completely flat thing because it has no thickness. And no width. It's just a completely small. It's just a position in space with nothing. Does it make sense?
Mm-hmm.
If there's a way, it can't really be defined. Okay, good. All right. So Marcus, go ahead and read this next one.
A point is named with a capital letter. Which point is the furthest to the right?
Yeah. So that's kind of easy, right? Which point, Marcus?
Why?
Why, right? All right, excellent. Okay. Now let's go ahead and Celeste read the next one.
What is a midpoint? A midpoint is a point that cuts a segment into two equal parts. It cuts it in half.
All right, good. All right, so do you notice the 3 and the 1.5, 1.5? So midpoint is that point there, that point here. And then Max, give me some numbers that you want me to make this one into a midpoint. How would I make that into a midpoint? What would I need to put here and here? Give me numbers.
3 centimeters.
3 here, and then what else?
3 there.
3 there, right? Because it needs to be exactly the same. Now, and this is an introduction. That's part of the reason why you see these little lines right here. When you have these lines, those are congruent lines. We're eventually going to discover the word congruent, which means equal. Now, why do we use the word congruent instead of equal? Any idea?
Is it like a different definition, like for similar or something? I don't know.
In a way, yeah, because see, what ends up happening is that we're talking about like, even though we could take a shape and equate it to numbers,
That's not
equal. Yeah, it's not necessarily like a number; it's more like a shape. So they call it congruency instead of equality, but they almost mean the same thing. All right, good. So now let's go to the next one. So let's read this one.
Coordinator versus non-coordinator points.
Okay.
Coordinator points, points that are on the same line.
Good.
Non-collinear points that are not on the same line.
Okay, Marcus, so give me some collinear points.
A, C, and D.
Yeah, pretty simple, right? Collinear, ooh, hold on, I'm using yellow and there's no contrast. A, C, and E, and I'll use green. And then Max, give me some non-collinear. Oh, hold
B
on.
and D are exception.
Yeah, B and D. It looks like with this yellow background, I use red and green and purple. All right, good. Okay, so now let's okay, so here they they also named A. Like you see how they put B, A, and C? These are technically non-collinear because they don't lie in the same line. Does everybody see that?
Mm-hmm.
All right, good. And the collinear, like you said, A, C, and E. Okay, so let's go with the next one. Marcus, why don't you answer this one? Which 2 points are collinear with A?
D and C.
Good. So, it's D and C, right? But do you see it as an answer choice in here?
Oh, I
here.
see C and D.
Actually, no, it's right here, C and D. So it could be the other way around, but as long as both of them are in there. Okay, so now let's go ahead and here. Okay, it says graph the points and determine if they're collinear or non-collinear. So let's go ahead and graph them. Let's discover if they're collinear or non-collinear. All right, so now walk me through this. So Marcus, how do I graph this point? Like if I want to graph P, what do I do?
Okay, so you'd go to -3 on the x-axis, then
So now let me tell you a way that sometimes elementary or middle school teachers are explaining it. It's very easy and simple. They talk about like walking, because remember you always start here at this origin spot, and you always talk about walking, and then afterwards, so like I would walk this way, then I would take the elevator up or down. So like in this case, I would take the elevator down, and this is P, right? So that I would do the same thing here. -1, 1, A, and then afterwards 2, 2. All right, and what do you guys think? Collinear or non-collinear?
non-collinear,
Yeah, right? Why?
because they don't make a straight line.
They don't make a line, right? So non-collinear. Let's get the next one. Okay, now what about this one? Oh, let's graph them. Sorry. -1, 2, 0, 0, -2, 4. Okay, so collinear and non-collinear.
Linear.
Yeah.
That's O. Should label it D. And one thing that is important that, oh, hold on, D's over here. I love about points is that for the most part, they're just labeled with the letter. That's all you need to label a point is a letter. So this is T, so this one is collinear. Okay, good. Okay, now go ahead, Marcus, read this next slide.
A line is a series of points that extends indefinitely into 2 opposite directions.
Yeah, all right, good. All right, Max, go ahead and read this next one.
How do you name a line? A line is named with any 2 names points that are on the line, and a line with 2 arrows on top of the letter or a lowercase letter that is not a point next to the line.
Yeah, so basically we're saying, so Marcus or Celeste, why don't you go ahead and tell me, give me 2 points to name this line.
2 points.
Yeah, give me 2 points off the line.
G&J.
Okay, how about your sister, kids?
I think it's G and J.
G, well, you could use G and J. So G and J, what's the only thing I need to do now? I use G and J, right?
Mm-hmm.
I gotta draw like a little arrow symbol. Now, would it be the same thing if I use J and G? Would this mean the same thing?
Yeah?
Yeah, absolutely. It would mean the exact same thing. You still get the same solution. So, Marcus, give me a different result to name this line.
I and H.
Yeah, I and H. The only thing really I need is this. We're there. All right, good. So now let's Celeste, stop. Celeste, go ahead and put the phone or put yourself on stop video and then come back. Okay? All right. Okay, good. Okay, so now let's go ahead and do this. All right, so let's see. Marcus, why don't you go ahead and name this? Which is not a good name for the line?
GIA.
Which one
Yeah,
is it?
GIA.
Yeah, GIHY.
Because they're using 3 points.
Yeah, exactly, right? Good. Okay, now let's do this next one. Why don't you go ahead and circle the correct name for the line? Which one would you tell me to circle? I'll circle all the 9 names that apply. So you see J and I, should I circle that one?
Yeah?
Yeah, good. What about the next one? Should I circle that one?
Yeah?
Next one?
Yeah?
Yes.
Yeah. Next one, HI.
Yeah?
Good. And the next one?
I don't know. No?
Yes. Yes. You can call it a line, you call it a line in. And the reason being is because you see, it's kind of hard to see over here because we're in the screen. But right now, that little N, you could, a lowercase letter will name a line. So that's another one. But what about this last one?
No.
No. Because you can use the name of the line and a point off of it.
Good point.
Yeah. Pretty good. All right. So let's go ahead and Celeste, read this slide.
What is a plane? A plane is a flat surface that extends indefinitely in all directions.
All right, good. Hey, listen, so if you were in my class, if we were meeting up all together and we're playing with this Play-Doh, I would have had you make a plane using the Play-Doh. So what would your kids do most of the time? You know what?
Make it flat.
Make it flat, right? And yeah, I would say that the majority of the time, they'll be like, okay, they will make a flat, you know, like square on their thing.
It will look
And
like a
yeah, it would look like a little, it look all kinds of stuff. But the thing that was important was this, when nobody could get it right. But does anybody know why? If you make something fly like what you're imagining, why is that not a plane?
Because it has to extend to all directions.
Yeah, so guess what I had them do afterwards?
Draw arrows.
Yeah, they had to make some arrows. They had to make little arrows with the Play-Doh. They would take parts of the Play-Doh or whatever Play-Doh they had left and make arrows to think about this concept in a physical sense that we're extending everywhere. Okay, kind of like a Minecraft world that you go everywhere in that spot, in that exact location. All right, good. So with that, Max, go ahead and read this.
How do you name a plane? A plane is named with a capital letter. Parenthesis. That is not a name point. Or 3 non-collinear points on the plane.
Yeah, so notice, read the 2 bottom ones, like here.
Plane R or plane X, W, Y.
Yeah, exactly. Now, why do we need 3 points, though? Anybody? I'll open this up to any of you 3. Why 3 points?
Well, because if you only put 2 points, that means it could be a line.
Yeah, exactly. You're definitely right about that, Marcus. And what does the third element add to it?
Width? I don't know.
Like height. Remember, like 3D shapes, you need width, length, and height.
Mm-hmm.
Yeah.
Oh,
But to discover a position in a plane, you need at least some kind of location marker that gives you about the same as a result. Okay. All right, good. Okay, now listen, let's go ahead and do the next one. All right, so let's go ahead and name this plane 3 different ways. So why don't we start with, let's start with Max. Max, name this plane. Give me a name for the plane. What would I write down?
name this plane below in the B plane.
Plane B. Yes, you're right. You can name the plane B. And it has to be capital, right? Okay. Celeste, give me another way to name this plane. Marcus, can you help her out?
Letters.
Yeah, Marcus. Let's go ahead and give me 3 letters off here.
Yeah, just use letters on there.
Yeah. So let's use E and P. Does it make sense? You just need to pick out 3 letters and you can name a plane. Now, very important. Notice how I'm like writing down plane every time.
Mm-hmm.
Yeah, same thing here. Marcus, go ahead and name me the 3.
EPL.
EPL. Yes. And can I switch the order of these if I wanted to?
Yeah.
Yeah, pretty much. Cool. All right. Now let's do the next one.
But Dad, can you
Yes.
excuse for a bit?
Yeah, go ahead and just stop the video and mute yourself.
Okay.
Yeah. All right, good. Okay. So now, Max, what would you read the question and then tell me what to do?
Shade the plane that contains the point NP and Q.
Okay, so where would I shade?
NP and Q. The bottom one.
The bottom one, right?
Or
Shade this bottom. Yeah, excellent. So yes, you're right about that. Okay, now Celeste, read the next one.
What is the intersection of plane ADC and plane BFG?
Okay, so ADC is up here.
It's the top.
Is the top one, and then BFG.
To the right side.
Yeah, the right side, right? Okay, so what is the intersection of this plane? Do you know what it is, Max?
C and B.
It's a line.
Line and
Yeah,
point.
and actually, since they're planes, I don't want to draw points at the end. You got to think that these planes extend forever, so do the lines. So we would say it's line BC with a little line symbol. Because remember, those boxes, they're kind of like the box you would draw. Remember when you're doing the Play-Doh, I was saying that most people draw a square? They go forever. So these go forever in every direction. These planes.
Yeah.
You know, same thing on the other side. All right, good. Okay. Now, go ahead and read this, Celeste.
Coplanar versus non-coplanar.
Yeah, coplanar versus non-coplanar. Okay, so and read the bottom.
Coplanar. Points on the same plane. Non-coplanar. Points not on the same plane.
All right, good. So, there's probably Max, give me a point that's well, actually, which is the only point that's not coplanar on here?
It doesn't say.
Yeah, this unknown right here. That's the only one that is non-coplanar. Does that make sense?
Yeah, I didn't know.
Yeah, all the other ones are actually on the plane.
They got no letters.
Yeah, and I'm imagining that's the next question they're gonna give us. Is give us an example to do. Like you see, the coplanar points was W, X, T, and Y, and actually Z as well. At least what it's showing. So let's put Z on here. And let's take it off here. Then over here in blue, they did name it P. Oh, you know what they did? I'm sorry. Let's see, P. Yeah, PY. No, you could actually do this if you wanted to. Okay, these points could be all non-coplanar. Do you know why? Because you see how it's out of here, so it makes its own plane. So P, Y, T, and Z. This would make a plane, but the plane would be like somewhere else. Does it make sense?
Oh, you're right.
Yeah, your plane would be somewhere else. So if I drew it in, these blue ones would be with like that one somewhere else, intersecting it. All right. So now let's go ahead and move on to the next slide. And let's go ahead and have Max, why don't you go ahead and read this one?
Which line is coplanar with JK and KL? Trace the lines and put the answers in the yellow box.
Okay, so JK.
JK. Yeah, highlight that stuff, please.
Yeah. Let's do JK, right? And KL. So here's the line KL. And here's the line JK. Okay. So which line is coplanar with JK
My hypothesis is N.
and KL? Trace the lines and put the answers in the yellow box. Okay. I guess what they're asking you is which other line is coplanar? Like, first of all, what plane do these sit in?
The top plane? I
Yeah,
don't know.
yeah, you're right. It's top plane. Okay, so give me another line that could be coplanar to these.
M and J?
Yeah. You see this one right here?
Mm-hmm.
So line
Oh.
MJ, and then give me another one.
M and L.
M and L. Good.
Wait, Daddy, where's the J? I'm looking at this box and I'm not finding a letter that's named J.
That one. That's the J. You see it now?
Yeah.
That's the one that's J. All right, excellent. Okay, good. Let's go ahead and go over to the next one. So let's read this one.
What is a ray? A ray is part of a line that starts at an endpoint and extends indefinitely in one direction.
Good. All right, so it's like a cutoff line almost. And all right, Max, read this next slide.
How do you name array? Array is named with the endpoint written first and a point on the array written second. There's an arrow pointing to the right on top of the letters.
Yeah, and this is the thing that most people have a hard time sometimes understanding, and that's that. Okay, does everybody see how this one points this way? You know what's the
Yep.
most common thing I get for this ray as a solution? As a result, I normally get this. You notice, you see how it's written on this one? This is wrong. Why?
Oh,
Why is that wrong?
because it's always pointing to the right.
Always pointing to the right. Exactly. You're always right, array pointing to the right. And the second most common mistake is I would get, why is this one wrong?
Isn't it R to Y?
Yeah,
Because of the
yeah,
point. Always pointing.
yeah, endpoint is written first. That's the other reason why. So like when you see this one's correct, the end, and then FE because of those two qualities that it contains, those two results of it. Okay, so let's go ahead and now let's move on to all together. Let's do the next slide. Okay, so circle. Okay, so I said, which one would I circle for this? What is the correct name for this ray?
Oh, the correct one is at the bottom of the middle.
Actually, no.
No, it's A, B. So
Yeah.
Yes,
No, that's all right. And actually, you learn most by mistakes. Remember, our biggest learning happens from mistakes. And so I'm glad you brought that up. Because first of all, the endpoint A is there, and then the arrow pointing to the right. So,
Daddy, is that when you said it always points to the right? I thought the arrow was going that way.
oh, you imagine that? Yeah. No, I know. And then there'll be a bunch of people doing the same thing. So I get you. I definitely get you. Okay, let's go ahead and move on to the next one. And Max, why don't you read this one?
EF line and FE line are on the same line. Are they opposite rays? Explain.
Okay, so EF and FE are on the same. Are they opposite rays?
No, they're in the middle. That doesn't
Yeah, no. Why? Because remember,
because
EF.
you had D as one of the points, then it will be opposite rays.
Well, not only that, but look, check it out. You see how this is doing? Remember FE? Oh, yeah, FE goes that way. Okay. You notice this overlap right here? Let me try to highlight it.
Chess.
Yeah, that overlap, you're not supposed to have that in opposite rays. So that's the reason why it's a no. No, no overlap. I put no twice. No overlap.
Okay.
Okay, so, all right, Marcus, welcome back. Go ahead and read this next
Hello.
one.
What is a segment? A segment is a part of a line that has two endpoints.
Good. Celeste, read the next one.
How do you name a segment? A segment is named with its endpoints and a line with no arrows on top.
Yes. Okay, good. So does everybody notice how this line right here, AB, how they have it as AB, no arrows on top, or you can name it the other way around?
Yeah?
Same thing goes with the other ones. MN, same thing, the two letters but no, just a line. So if I was going to write this one, I would do the same thing. VW, same thing. All right, good. Okay, so now let's go ahead and do this. All right, Marcus, tell me which one should I circle? What's the correct name for this segment?
Or the first, no, actually, the first one.
The first one is the correct one, right? Is that the only one?
Nope.
Then the one directly below it.
Yes, excellent. All right, good. All right, let's see. Let's have Max read this next one.
Marcus, how do you say that word?
Okay, Marcus, read this next one.
What is a postulate? A postulate is a statement that we accept to be true without any proof.
Yeah, so some of the things that, so they can be proven, kind of like line, point, well, they're like, some of the stuff can be proved, line, point, and plane, but we just know they exist. All right, let's go ahead and, Max, why don't you read this one then?
How many different lines can you draw through the 2 points below? Show your work below and put the answers in the yellow box.
All right, good. So how many lines can I draw?
2.
I can draw 2.
Yeah, B and A and B, or is that the same thing? Is that 1 point?
It's the same thing.
It's the same thing. Yeah, and actually I'm trying to draw something a little bit straighter, so I'm trying to use this little line tool. But you're going to discover that for the most part, there's only one line that exists. One line that exists for any 2 points. Okay, because there's only one. So this one, even though there's different ways to name it, there's only one that actually is there. No matter
Yes,
which
sir.
way you think about it, right? Okay, good. So now let's do this next one. So I have to read this.
Postulate number 1. Through any 2 points, there is exactly one line.
Yeah, so it just proves our point, but we came up with it. That's one thing that I love about it. Okay, now let's do the next one. Okay, Marcus, read this next one.
How many different points can two lines intersect? Draw two lines that cross and see.
Okay, good. So, Marcus, what do you think? I drew a line.
Mm-hmm.
How many different points
You have
can
to draw two.
Yeah. So, how would you want me to draw the next one?
Like an X, perpendicular.
Oh, perpendicular will look like this, right? So, what do you come up as a conclusion?
Well, I guess it's just a square or a shape, some sort of weird kite.
Yeah, I know, but look at the question itself, bro. How many
How many?
points can two lines intersect?
One.
Yeah, just one. I know. And no matter how you draw these lines, like let's say I take this line that's here and I make it intersect anywhere else. Notice how anywhere I make it intersect on the other line, it's only one as a result. Yeah, so that's one thing that we find out and we discover. Now let's see this next one. So here's so read this, Marcus.
Two lines intersect in exactly 1 point.
And good. Okay. Max, read this next one.
What geometrical shape is formed by these two inserting planes?
Yeah, intersecting planes, right? So Max, what shape is formed?
A cross.
No, not really. Marcus, do you know?
A line.
Yeah, it's a line. Basically here to here. Since this planes go on forever, so you got to think about this plane going on forever in every direction. Same thing with this one. We discovered that these are lines. as a result. So there would be a line. All right. So Celeste, read this next slide.
Postulate number 3. The intersection of two planes is a line.
Good. All right. So now let's go ahead and next. Oh, Marcus, read this one.
Draw three collinear points A,
Collinear.
B, and C, where the two planes intersect. Which plane can be named plane ABC? Is it plane B or plane N? Write your answer in the yellow box.
All right. So draw three collinear points, A, B, and C. So collinear just means
Just like straight.
which plane can be named is it plane R or plane N? Kind of hard, right? Well, here.
No.
I think the solution comes here. Read this, Marcus.
Through any three non-collinear points, there is exactly one plane.
Yeah, so when we come back here, this one would have been like you guys were saying, plane R, right? So through three collinear points, it shows that there's exactly one plane as a result. All right, good. Okay. Now, Celeste, read this next slide.
Draw a line through points P and G. Where is the line? On plane R or off plane R?
Okay, so draw a line. So, Marcus, what do you think? Where is the line? Is it on plane R or off plane R?
On,
On. Why?
because the points are inside of
Yeah,
it.
the plane goes on forever, right?
Mm-hmm.
So, Max, read this postulate.
2 points lie on the plane, then the line containing those also lies in the plane.
Yeah, so basically, any points on the line will also lie on the plane. Is really what it's saying. Since we discovered that they go on forever. All right, now let's look at the next one. Celeste, read this next one. Oh, this is it. Okay, so kids, share. Celeste, tell me one thing you learned about today.
I learned that there is collinear and not collinear because at my age we haven't learned this stuff yet.
That's good. All right, Marcus, tell me something you learned about it.
There's many postulates in math.
And many postulates in math. So that means that with some of these postulates, what's the biggest thing about a postulate that you remember?
It's a given fact that you don't have any proof to back it up.
Very proof, right? All right, good. Okay. Okay, so that's good. That's good. All right. Hey, listen, we are done. So after this, now remember, every watching this video, I expect for you to go ahead and write these notes down on a separate sheet of paper. You're gonna upload them to me. I'll show you a video how to do that, and then we'll go ahead and continue our activities for today. All right, good. Hey, everybody, say bye.
Bye.
Bye.